save the world. We were meant to leave it. This striking phrase from Interstellar reminds us of something inevitable. Humanity has always sought to go further, explore the unknown, and find new horizons. But what will future space travel look like? Will we be able to overcome the barriers of deep space, colonize other planets, and, who knows, even reach other galaxies? Today, we'll explore the technologies, challenges, and ideas that can make this dream a reality. Because ultimately, the future of space travel could be the key to humanity's survival. Traveling to space has always been one of humanity's biggest dreams. Ever since we first looked up at the sky, we've wondered, what's out there? And, most importantly, how can we get there? But while science fiction shows us interstellar ships crossing galaxies in seconds, reality is much more complex and much more challenging. Space is a hostile environment. There is no air to breathe. Extreme temperatures can destroy equipment, and cosmic radiation poses a constant risk to human health. Furthermore, the distances involved are unimaginable. To give you an idea, the closest star to our solar system, Proxima Centauri, is about 4.24 light-years away. This means that, even traveling at the speed of light, something that is currently far beyond our technological capabilities, it would take us more than 4 years to get there, and that's just the beginning. So what will future space travel look like? How will we overcome these seemingly insurmountable barriers? And, perhaps most importantly, why are we so determined to explore deep space? The answer to the last question is simple: survival. As theoretical physicist Stephen Hawking said, humanity will not survive another 1,000 years on Earth without escaping beyond our fragile planet. Climate change, pandemics, nuclear wars. There are countless threats that could make the Earth uninhabitable. And while we can work to mitigate these risks, the truth is that in the long term, our survival depends on becoming a multiplanetary species. But to do this, we need to solve a series of problems. The first is the issue of propulsion. Currently, our spacecraft rely on chemical engines, which are effective for short trips within the solar system, but completely inadequate for interstellar travel. To reach the stars, we need something much more advanced, something that is still in the realm of theory. One of the most promising ideas is nuclear fusion propulsion. Nuclear fusion is the process that powers the sun, releasing enormous amounts of energy by fusing hydrogen atoms into helium. If we can master this technology, we could build spacecraft capable of traveling at a significant fraction of the speed of light, reducing the travel time to nearby stars from thousands of years to just a few decades. Another idea is the use of solar sails, which take advantage of the pressure of sunlight or lasers to propel spacecraft. This technology has already been tested on a small scale, with projects such as the Planetary Society's LightSail and Breakthrough Starshot, which plans to send tiny probes to Proxima Centauri using powerful lasers. Although still in its early stages, solar sail propulsion has the potential to revolutionize space travel. But propulsion is only part of the problem. We also need to resolve the issue of sustainability. How do you keep a crew alive and healthy during a voyage that could last decades or even centuries? This means developing life support systems that can efficiently recycle air, water, and food, as well as protecting astronauts from cosmic radiation and the effects of microgravity. And then there is the issue of colonization. Even if we manage to get to another planet or moon, how are we going to turn it into a habitable place? This brings us to the concept of terraforming, the process of modifying a planet's atmosphere, temperature, and ecology to make it Earth-like. Mars is the leading candidate for terraforming, but the process would be incredibly complex and take centuries, if not millennia, to complete. But despite these challenges, humanity has never been one to back down in the face of the impossible. From the invention of the airplane to the arrival of man on the moon, we have always found ways to overcome the barriers that separated us from the next big thing. And when it comes to space travel, it will be no different. What makes this challenge even more exciting is that it's not just a question of technology, it's a question of imagination. Because at the end of the day, space travel isn't just about exploring space, it's about exploring what it means to be human. They force us to confront our fears, expand our horizons, and dream of a future that, however distant it may seem, is within our reach. These are the questions we will explore throughout this video, because, as much as space travel is a challenge, it is also an opportunity, a chance to redefine who we are and what we can achieve. The idea of traveling to space is not new. Since ancient times, humanity has looked up to the starry sky and imagined what could lie beyond. For many cultures, the cosmos was the domain of the gods, a sacred and unreachable place. But even so, dreams of exploring the unknown were always present. First, as myths, then as scientific ideas, and finally, as concrete projects. In Greek mythology, for example, we find the story of Icarus, who tried to fly to the sky with wings, made of wax and feathers. Although his attempt ended in tragedy, the story symbolizes the human desire to go beyond one's limitations. In ancient China, there are records of rudimentary rockets used in celebrations and wars, showing that the idea of using technology to reach the sky had existed for centuries. But it was only in the 17th century, with the advent of modern science, that we began to think seriously about traveling to space. Astronomer Johannes Kepler, for example, wrote a book called Somnium, The Dream, in which he imagined a trip to the moon. Although it was a work of fiction, Somnium was one of the first attempts to approach space exploration in a scientific way. In the 20th century, the idea of space travel began to become a real possibility. In 1903, Russian scientist Konstantin Tsiolkovsky published a paper entitled The Exploration of Cosmic Space by Means of Reaction Devices, in which he described the basic principles of modern rockets. Tsiolkovsky is often called the father of cosmonautics, and his ideas have inspired generations of scientists and engineers. But it was during World War II that rockets really began to gain prominence. German scientist Werner von Braun developed the V-2 rocket, which was used as a weapon, but also served as the basis for the rockets that would take man into space. After the war, von Braun was taken to the United States, where he played a crucial role in NASA's space program. And then, in 1957, the Soviet Union launched Sputnik, the first artificial satellite in history. This event marked the beginning of the space race, a competition between the United States and the Soviet Union to dominate space. Just 4 years later, in 1961, cosmonaut Yuri Gagarin became the first human being to travel into space aboard the Vostok 1 spacecraft. His mission lasted just 108 minutes, but it was a milestone in human history. The space race reached its peak in 1969, when the United States sent the first astronauts to the moon. The Apollo 11 mission, led by Neil Armstrong, Buzz Aldrin, and Michael Collins, was an extraordinary feat, which showed the world what humanity is capable of achieving when dedicated to a common goal. As Armstrong said upon stepping onto the lunar surface, "One small step for man, one giant leap for mankind." But after the end of the space race, interest in space travel began to wane. During the 1970s and 1980s, the focus shifted to robotic exploration, with probes such as Voyager and Pioneer being sent to explore the planets of the solar system. While these missions have made incredible discoveries, they have also highlighted the challenges of sending humans into deep space. However, in recent decades, interest in space travel has grown again. This is due, in part, to the emergence of private companies such as SpaceX, owned by Elon Musk, and Blue Origin, owned by Jeff Bezos. These companies are developing technologies that promise to make space travel more affordable and sustainable. SpaceX, for example, has already flown crewed missions to the International Space Station and plans to send humans to Mars in the next decade. Furthermore, science continues to advance. Telescopes like Hubble and James Webb are helping us better understand the universe, while missions like Perseverance on Mars are looking for signs of life on other planets. These advances are bringing us closer and closer to the dream of exploring deep space, but at the same time, they also remind us how far we still are from that goal. Because no matter how much we have achieved, deep space remains an immense challenge. A challenge that requires not just technology, but also imagination, courage, and determination. And this leads us to a fundamental question. What will the next chapter of space exploration look like? Will we be able to overcome the barriers of deep space and become a multiplanetary species? Or will our dreams of exploring the cosmos remain just that, dreams? These are the questions we will explore throughout this video. Because at the end of the day, the story of space travel isn't just about what's out there. It's about who we are and what we're capable of achieving. If there is something that defines humanity, it is our ability to turn dreams into reality. And when it comes to space travel, advances in recent decades show that we are closer than ever to exploring deep space. From reusable rockets to missions to Mars, science and technology are taking us to places that previously only existed in science fiction. One of the biggest recent milestones in space exploration has been the development of reusable rockets. For decades, rockets were disposable, used only once, and then abandoned in space or destroyed upon re-entry. This made space travel incredibly expensive and limited the number of missions we could fly. But in 2015, SpaceX changed everything. For the first time, the company has managed to land a reusable rocket, the Falcon 9, paving the way for a new era of more accessible and sustainable space exploration. Since then, SpaceX has used this technology to reduce mission costs and increase their frequency, making space more accessible than ever. Another impressive advance is the Starship project, also from SpaceX. This spacecraft, currently in development, is designed to be fully reusable and capable of transporting large payloads and crews to destinations such as the Moon, Mars, and beyond. With its ability to land and take off on different planetary surfaces, Starship promises to be a game-changer in space exploration. Elon Musk, founder of SpaceX, has already stated that his goal is to use Starship to establish a human colony on Mars in the coming decades. And it's not just SpaceX that is innovating. NASA is also working on ambitious projects, like the Artemis program, which aims to return humans to the moon by 2025. But this time, the goal isn't just to visit, it's to establish a permanent presence. The idea is to use the moon as a testing ground for technologies that will be needed to explore Mars and other deep space destinations. This includes life support systems, inflatable habitats, and even mining lunar resources to produce fuel and water. Additionally, NASA is developing the SLS space launch system, the most powerful rocket ever built, designed to carry heavy payloads and cruise beyond Earth orbit. Combined with the Orion capsule, the SLS will be a key player in missions to the Moon and Mars. But the innovations don't stop there. Scientists and engineers around the world are exploring new forms of propulsion that could take us further, faster. One of the most promising ideas is nuclear fusion propulsion, which could enable interstellar travel in a fraction of the time needed with current chemical engines. Although it is still in the experimental phase, nuclear fusion has the potential to revolutionize space travel, making it possible to reach nearby stars in decades rather than centuries. Another revolutionary technology is solar sail propulsion, which uses light pressure to propel spacecraft. Projects like Breakthrough Starshot plan to use powerful lasers to accelerate tiny probes equipped with solar sails to a significant fraction of the speed of light. These probes could reach Proxima Centauri, the closest star to our solar system, in just 20 years, a feat that would be impossible with current technology. And then there are robotic missions, which continue to pave the way for human exploration. On Mars, the Perseverance rover is collecting soil samples and looking for signs of past life, while the Ingenuity helicopter is testing the feasibility of flights in extraterrestrial atmospheres. These missions not only help us better understand the Red Planet, but also provide crucial data for future crewed missions. Furthermore, the exploration of moons such as Europa from Jupiter and Enceladus from Saturn is bringing us closer to the possibility of finding extraterrestrial life. Both moons have subsurface oceans covered in ice sheets, and future missions, such as NASA's Europa Clipper, plan to probe these environments for biosignatures. But perhaps the most exciting development is the growing collaboration between governments, private companies, and international organizations. Space exploration is no longer the exclusive endeavor of superpowers like the United States and Russia. Countries like China, India, and the United Arab Emirates are investing in their own space programs, while private companies like Blue Origin, Rocket Lab, and Virgin Galactic are pushing the boundaries of what's possible. This diversity of actors is accelerating the pace of innovation and making space more accessible for everyone. However, with all these advances, there are still significant challenges to be overcome. How to protect astronauts from cosmic radiation during long trips. How to create life support systems that can function self-sufficiently for decades. And, perhaps most importantly, how can we ensure that space exploration is sustainable and ethical, avoiding repeating the mistakes we made on Earth? These are questions that still do not have definitive answers, but at the same time, they are a reminder that space exploration is not just a matter of technology, it is a matter of imagination, courage, and determination, because at the end of the day, space travel isn't just about what's out there, it's about what's inside us. They challenge us to dream, to innovate, and to believe that the impossible is possible. And as we continue to explore the cosmos, one thing is certain: the future of space travel will be as extraordinary as the dreams that got us here. Behind every advance in space exploration, there is a dark side, a side that rarely appears in the headlines, but that is as real as the rockets we launch into the sky. Because as we dream about deep space travel, we also need to confront the challenges, risks, and controversies that come with them. One of the biggest problems is the astronomical cost of space travel. Developing rockets, spacecraft, and advanced technologies requires billion-dollar investments, and many question whether these resources could not be better used to solve problems here on Earth, such as poverty, hunger, and climate change. While proponents of space exploration argue that it brings indirect benefits, such as technological advances and inspiration for generations to come, the question remains: how much are we willing to spend to reach the stars? And then there is the issue of environmental sustainability. Space may seem infinite, but Earth's orbit is becoming increasingly clogged with space debris, pieces of decommissioned satellites, rocket stages, and other fragments that pose an increasing risk. 2. Future missions. In 2021, the International Space Station had to perform several maneuvers to avoid collisions with space debris, highlighting the urgency of dealing with this problem. Additionally, rocket launches release large amounts of carbon dioxide and other pollutants into the atmosphere, contributing to climate change. Another significant challenge is cosmic radiation. Outside the protection of Earth's magnetic field, astronauts are exposed to dangerous levels of radiation, which can cause cancer, damage to the nervous system, and other health problems. Although technologies are being developed to protect crews, such as radiation shields and underground habitats, we are still far from a definitive solution. And then there are the psychological and social effects of long-duration space travel. Spending months or years in a confined, isolated, and hostile environment can have a profound impact on astronauts' mental health. Studies carried out on the International Space Station show that prolonged isolation can lead to stress, anxiety, and even conflicts between crew members. These challenges will be even greater on missions to Mars or beyond, where astronauts will be completely disconnected from Earth. But perhaps the biggest dilemma of all is the ethical issue. As we venture into deep space, we need to ask ourselves, what right do we have to explore and possibly colonize other worlds? Are we repeating the mistakes of the past, when European explorers colonized lands inhabited by indigenous people, often with devastating consequences? And if we find life on other planets, how do we ensure we don't destroy it or exploit it for our own benefit? These questions are particularly relevant when it comes to terraforming, the process of transforming a planet like Mars into a habitable environment for humans. While terraforming is often presented as a solution for humanity's survival, it also raises profound ethical questions. Do we have the right to modify an entire planet to suit our needs? And if Mars is already home to life forms, even if they're just microorganisms, how do we ensure we don't wipe them out in the process? And then there is the issue of privatizing space. With the emergence of companies like SpaceX, Blue Origin, and Virgin Galactic space exploration is becoming increasingly dominated by the private sector. While these companies are driving innovation, they also raise concerns about inequality and access. Who will have the right to explore and profit from space resources? Are we creating a future in which only the richest and most powerful will have access to humanity's greatest discoveries? Furthermore, there is the risk of militarization of space. Although international treaties prohibit the use of nuclear weapons in space, the reality is that many countries are developing space technologies with military applications. Spy satellites, anti-satellite weapons, and even orbital strike platforms are just some of the threats that could turn space into a new battlefield. And finally, there is the risk of failure. No matter how advanced our technology is, space travel remains incredibly dangerous. From the Challenger disaster in 1986 to the Starship rocket explosion during a test in 2023, every mission carries the risk of catastrophic failure. These incidents not only put lives at risk, but can also slow progress and undermine public support for space exploration. But despite these challenges, humanity has never been one to back down in the face of the impossible. Because at the end of the day, space travel isn't just about what's out there, it's about who we are and what we're capable of achieving. They force us to confront our fears, question our choices, and imagine a future that, however distant it may seem, is within our reach. And perhaps that's what makes space exploration so fascinating. It's not just a question of technology or science, it's a question of imagination, courage, and determination. Because as vast and hostile as space is, it is also a reminder that, as long as we continue to dream, there are no limits to what we can achieve. We weren't meant to save the world. We were meant to leave it. This line from Interstellar isn't just a tease. It's a reminder that, at some point, humanity will need to look beyond Earth. But what does this really mean? And, more importantly, what does this say about who we are? Space travel is not just about technology or science. They are about the essence of humanity, our curiosity, our resilience, and our desire to explore the unknown, from the first steps on the moon to ambitious plans to colonize Mars. Each advancement in space exploration is a reflection of what makes us unique, the ability to dream the impossible and work to make it a reality. But at the same time, space travel also forces us to confront our limitations. They remind us that no matter how advanced we are still vulnerable, both as individuals and as a species. Because at the end of the day, space isn't just a place we go. It is a mirror that reflects our hopes, our fears, and our contradictions. Consider, for example, the impact that space exploration has already had on our view of ourselves. When the Apollo 8 astronauts took the famous Earthrise photo, showing Earth rising above the lunar horizon. They gave us a new perspective on our planet. For the first time, we saw Earth as it really is. A tiny blue dot floating in the vast emptiness of the cosmos. This image has not only inspired generations, but also reminded us how fragile and precious life is. And now, as we prepare to explore deep space, we are faced with a new question. What does it mean to be human in such a vast universe? Are we ready to become a multiplanetary species? And if we are, how do we ensure that we do not repeat the mistakes of the past, exploiting and colonizing without considering the consequences? These are questions that have no easy answers, but at the same time, they're a reminder that space exploration isn't just about what's out there, it's about what's inside us. Because at the end of the day, the biggest challenge of space travel isn't building rockets or surviving in space. It's learning to work together, to care for each other, and to value what we have. And perhaps that's what makes space travel so important. They are not just an opportunity to explore new worlds. They are an opportunity to rediscover ourselves. To remind us that, no matter how different we are, we all share the same home. And as we look up to the stars, we are reminded that humanity's future isn't just in space. It's in our hands. Because at the end of the day, space travel isn't just about leaving Earth. They are about finding a new purpose, a new hope, and a new way of seeing the world and ourselves.